Hey, guys, you ever wonder what it would look like if a whale and a dinosaur had a baby? Well, no need to wonder. There is an extinct group of marine reptiles called ichthyosaurs that fit this description perfectly. They were gigantic, sleek-looking, dolphin-like reptiles that lived entirely in the ocean. And like whales, they gave birth to live young. However, unlike whales, ichthyosaurs were more closely related to dinosaurs than to other marine reptiles like turtles or crocodiles. In fact, they were part of a larger group of reptiles known as archosaurs, which also includes alligators and birds. So these things were basically the aquatic equivalent of theropod dinosaurs like Velociraptor and Tyrannosaurus rex. But how did such iconic creatures disappear without a trace? Let's find out in today's episode. Ichthyosaurs first appeared during the Triassic period, around 245 million years ago. Like their closest relatives, the archosaurs, ichthyosaurs exhibited many adaptations for a fully aquatic lifestyle. Their bodies were streamlined, with paddle-shaped limbs and a powerful tail for propulsion. They also had large eyes, well developed for seeing in dim light, and small ears with little ridges and grooves, features which are only found in animals that live in water. Furthermore, they breathed air, but could spend their entire lives underwater, thanks to a special adaptation to utilize oxygen from low-oxygen environments. Some species were truly massive, like Himalayasaurus, which grew up to 8 meters long and weighed several tons. This would have made them apex predators in the Triassic seas, preying on smaller fish, and perhaps even on each other. Evidence suggests that some ichthyosaurs may have been capable of regulating their buoyancy through muscle contractions, enabling vertical movement in the water column. This contrasts with most modern whales, which use fat to control buoyancy. Ichthyosaurs didn't have blubber, so they probably had specialized muscles for this purpose. Despite being highly adapted to life in water, ichthyosaurs were not technically fish. They were classified as a type of reptile known as a parareptile. These were once thought to be early ancestors of modern reptiles, but recent studies suggest that they were actually more closely related to a group of mostly extinct land-dwelling reptiles called ariosauромorphs. Ichthyosaurs were therefore terrestrial animals that returned to the oceans multiple times throughout their evolutionary history, a trait they shared with another famous group of marine reptiles, the mosasaurs. As mentioned before, ichthyosaurs were members of a larger group called Archosauria, which split from the parareptiles around 300 million years ago. Archosaurs quickly diversified, giving rise to crocodilians, dinosaurs, and eventually birds. The earliest ichthyosaurs were relatively small, averaging about 2 meters in length. However, they reached their peak during the Jurassic period, when several giant species evolved, including the previously mentioned Himalayasaurus. Hematosaurus fossils have been discovered in both Europe and North America, indicating that these giants had a worldwide distribution. Another well-known genus was Shastasaurus, which reached a maximum length of 15 meters. The largest species of Shashosaurus, S. ceratops, was named after the Canadian paleontologist H. J. Sloboda, who collected the first fossil in 1928. Despite their enormous size, very few complete skeletons have been found due to their fragile bones, which were adapted for life in the water and not for life on land. While studying the Triassic seas, paleontologists also discovered another fearsome ichthyosaur, the aptly named monster of the sea, or in Latin, the monstrous womb of the sea. Seriously, that's its real name. It lived 228 million years ago in what is now Switzerland, and grew up to 9 meters in length. With such a formidable body shape, huge jaws, and hundreds of sharp teeth, it's easy to understand why this animal earned such a terrifying moniker. Yet its discovery surprised scientists for another reason. The remains of the monster of the sea were found alongside those of other late Triassic marine reptiles in what is known as the ghost lineage of ichthyosaurs. As their name implies, these creatures almost completely disappeared at the end of the Triassic, with only one confirmed species surviving into the Jurassic. But the monster of the sea turned out to be much older than originally thought. Researchers initially believed it was from the ghost lineage based on its anatomical similarities to other species in the group. However, A re-examination of its skull revealed features that it shares with much older ichthyosaurs, suggesting that the monster of the sea is much closer related to those animals than to the ghost lineage. These new findings have forced scientists to reconsider what happened to the ichthyosaurs. Perhaps they didn't experience a mass extinction at the end of the Triassic, but instead, there was a major diversification event leading to the evolution of several new groups of ichthyosaurs. Among them, the ghost lineage, the monster of the sea, and other large forms that dominated the Jurassic. This means that the story of ichthyosaurs is far from over. New discoveries continue to rewrite their history, even if we don't know all of the details yet. Unfortunately, the same cannot be said for the ending. Ichthyosaurs went extinct along with many other marine reptiles during the late Cretaceous period, around 66 million years ago, along with the dinosaurs. Scientists have long debated the cause of this mass extinction, but a recent study published in Nature Communications has provided new insights. It turns out that during the Cretaceous period, the Atlantic and Pacific Oceans became significantly warmer than they are today, possibly due to volcanic activity in Antarctica. And while ocean temperatures had risen and fallen before, this time things were different. During previous periods of global warming, ocean currents mixed cold water from the poles with warm water from the tropics. But by the late Cretaceous, the Atlantic and Pacific had become stratified, meaning that warm and cold waters stayed that way. No mixing. This led to a permanent thermocline, or a barrier between warm and cold waters in the ocean. This phenomenon negatively affected the growth and reproduction of marine organisms, including phytoplankton, the microscopic algae that form the basis of most marine food webs. Phytoplankton require dissolved minerals from the deep ocean to survive. But once the ocean became stratified, these vital nutrients were locked away and couldn't reach the surface. Many marine animals, including ichthyosaurs, died off as a result. Only a few clades survived, including the ancestors of modern whales, turtles, and some types of fish. So why does the story of the ichthyosaurs matter to us today? Aside from being awesome, marine reptiles like ichthyosaurs played a crucial role in shaping our planet's history. According to some scientists, the mass extinction at the end of the Cretaceous might not have been such a bad thing. It paved the way for the rise of mammals, which ultimately led to the evolution of our species. Others disagree, saying that the mass extinction at the end of the Cretaceous was a rare example of overkill, meaning that a single event caused the extinction of numerous species. In this case, the asteroid impact that triggered the Younger Dryas. This climatic shift might have doomed many species regardless of how warm the oceans were. Regardless, studying the history of life on Earth gives us insight into the workings of natural selection. Seeing how different organisms have changed and adapted over time helps us predict how species might react to future environmental changes. One of the reasons ichthyosaurs went extinct was because they were too specialized. They were superbly adapted to life in the open ocean, but that came at a cost. Their streamlined bodies, large eyes, and lack of limbs made them particularly vulnerable when they hauled themselves onto land to lay eggs or bask in the sun, making them easy targets for terrestrial predators. Their predicament highlights the advantages of being generalists. Animals like turtles and crocodiles can live both in and out of the water and feed on a variety of prey, whereas ichthyosaurs could do neither. Being specialists allowed the ichthyosaurs to thrive, but being generalists helped others survive. The same principle applies to us humans. Our brains are big, complex organs that require lots of energy to function. That makes us generalists when it comes to diet. We can eat just about anything, which allows us to live in a variety of habitats around the world. Some animals have benefited from becoming specialists, but our success as a species can be attributed in part to our generalized traits. Okay, but why should you care about what traits have allowed humans to spread across the globe? Because understanding the processes that drive evolution helps us make informed decisions about the future of our planet and its inhabitants. If we learn from past mistakes, we can help ensure that fewer species end up like the ichthyosaurs, magnificent creatures whose extinction robbed our planet of its monster of the sea. Thank you for watching. If you liked this video, please subscribe.